Our session today will discuss sampling, estimation, and hypothesis testing. To start with, we need to understand a few terms. What a sample is, what a population is, and why we do sampling. So a population is simply a set of all items and individuals. For instance, the population of voters in a country, all political parties, all sales receipts for November, that is a population. But a sample is a subset of a population. For instance, out of the whole list of voters, PF, out of all the parts that were produced today, we want to just select a few damaged ones. Out of all the receipts, we want to select a few for an audit. So sampling is important for the following reasons. Number one, we sample because of time. We sample because of the cost implication. We sample because of the statistical levels of precision, confidence levels. They say the smaller the sample size, the higher the accuracy level. So sampling has a number of techniques that you need to know. We have what we call simple random sampling. This is where objects are randomly selected independently to obtain a non-biased sample space. We also have different types of sampling. We have what we call probability and non-probability sampling methods. The probability sampling methods are to do with numbers. We have a number of probability sampling methods that you may wish to know. So these methods may include the simple random sampling method. They may also include systematic sampling methods. May also include what we call about simple random, systematic. The simple random is where you select samples randomly. The systematic is where you pick a certain pattern every 10th, every 11th, you pick. That is systematic. We have stratified sampling method where you are going to group your samples into strata, low, middle, and high management. We also have what we call cluster sampling. So these are the types of probability methods of sampling that you need to know. The cluster sampling involves you dividing the population into what we call subgroups. And in each of these subgroups, we should have similar characteristics. For instance, clusters of tribe from southern province, northern province, eastern province. So under non-probability sampling methods, yes, please.
Sorry, Mr. Collins. So is cluster sampling the same as stratified? Is it stratified or something?
No, stratified is where you divide the population into, it's similar, but for stratified, when you subdivide the population into subpopulation, that may differ in important ways. These populations may have top, middle, and lower management, that different salary scales. So these that we divide into strata are based on the relevant characteristics, whereas the cluster, you subdivide them into similar characteristics of a population. For instance, southern province or Patongas, northern province or Abembas. So they have a similar, except that the cluster sampling has what we call a multi-stage sampling strategy. Then when we go to the non-probability sampling methods, we're looking at a kind of sampling which does not include equal chances of being selected. there's a high degree of biasness in this non-probability sampling method. Examples that we have could be convenience sampling, purposive sampling, snowball, quarter sampling. Convenience is where you are going to select your individuals because you happen to be accessible to them as a researcher. It's very cheap because you conveniently position yourself. We also have what we call purposive sampling, which is also called judgment-based sampling, which involves you using your discretion and expertise to sample the most useful elements of the sample. Here, as a researcher, you want to get a detailed knowledge about a certain phenomenon. You're only going to pick a certain class. For instance, if you want to pick to find out the impact of the vaccines on on uh, on what can I say? Yeah, the vaccines of COVID on your health or your resistance towards certain. So you would want to specifically sample out a few those that have been vaccinated. You cannot sample the whole population. You purposely select those ones that are vaccinated. And snowball is where you use a recruiting kind of method where the participants will recruit other participants because of their knowledge or access to certain knowledge. Like a snow grows, it grows. It's kind of investigative where you want to find out who stole. They will tell you who else was there, etc. So basically, these are the types of sampling methods that you need to know on the theoretical part of this um, component. So under this, we are going to now look at estimation and sampling. The formulas that we need to know, first of all, are just 10. Under sampling, we have two formulas. Number one, sample size, N is equal to Z, the variance over the level of precision E. This is if you're using a sample. If you're using a population, Z PQ over E. S is called the variance standard deviation. Z is a Z score. I'll teach you how to get the table. Then E is the error, which comes as plus minus or the word within. P is a proportion, Q is a failure. So if P is 20%, Q is 80%, the two must add up to 1.
Is the Z score and the others?
So the Z score, the variance, and the error. The Z score, the P, and the Q, and the error. All right. Now, how do we get the Z? We have the confidence level, and the significance level, and the alpha and Z. So we have a song that we have learned. We have confidence levels that are above 50%. So we have 99, we have 98, and we have 95, and we have 90. The difference from 100 is called this significance level. 1%, 2%, 100 minus 95 is 5%, and 90 from 100 is 10%. So are we clear so far on how these percentages are extracted? I've given you the most common percentages that are given. If you're not given a percentage, the standard one is 95%. So when you divide this by 100, we call it alpha, 0.01. Divide this by 100, it's called alpha, 0.02. Divide this by 100, alpha, 0.05. If you divide this by 100, alpha, 0.10. This alpha is a two-tailed test. So estimation, we only always use a two-tailed. So don't mind about this. I'll explain later how to get this. But for now, I need you to memorize. The Z for 99%. Who can remember? What is Z for 99%? 2.58. The Z for 98, 2.33. The Z for 95, 1.96. And the Z for 90, 1.65. So this is how we get the Z figures. You need to memorize them for now. Then under estimation, we only have 4 formulas. Number 1, confidence interval. The mean is given by X bar plus minus the error. Or to expand this, our confidence interval is equal to the mean plus or minus the Z standard deviation over square root of n. If you're using a proportion, we're going to use the proportion plus or minus Z. Then here we have P Q over the capital N. So confidence interval is simply a range between the lower bound and the upper bound. The lower bound is a small number, the upper bound is a bigger number. So to get the mean, you can simply add the lower bound plus the upper bound divided by 2. To get the error, you can simply subtract the lower bound from the upper bound. We divide by 2. And under hypothesis testing, what you just need to know is the Z calculated, which is simply given by the mean X bar minus mu over standard deviation. Standard deviation over root n. If you're using a proportion, we're using proportion minus P over PQ divided by N. Anyway, what am I talking about? Let me demystify these mysteries. The starting point is our song here. 99 is 1%. 1%, 0.01, then 2.58. So I want you to take a little bit of some time to look at this and memorize it. Then we get to memorize this so that we can look at the questions to do with estimation. All right, so let's start this table again. How do we find the confidence levels? Confidence levels are the degree to which your premise is given an estimate.
Sorry, Mr. Kon, let me just see.
99.
Let me just see the previous.
The difference between 9% and 100 is what?
1%.
1%. Then when we divide this 1% by 100, what we get?
0.01.
0.01. How about when you divide this 0.01 by 2, what do we get?
0.0525. 0.0.
Okay. Then when we subtract 1 minus 0.005, what do we get?
It's the 0.995.
0.995.
95.
So this is to read that from the table.